Let's talk about the chapter known as related rates. Okay, related rates. This is one of the scariest chapters in EG2 module. The reason it's scary is because the questions are quite hard to do. But then again, the questions are hard to do because it's quite difficult to understand what it's asking for in the first place. So let's see whether we can, number one, understand the question, find out what it's asking, and let's see whether there is a shortcut way of doing well. It's not really a shortcut way, but an easier way and hopefully a sort of a template to help you solve this question. Okay, so related rates. Let's look at this particular question and find out what it wants. It tells you that there's a ladder that leans against a wall. Okay, so let's draw a ladder that looks something like this. This is obviously my wall. Okay, this is the wall here, and that's my ladder. Okay, it's leaning against here. While a pail is placed 2 meters away from the wall, if the top of the ladder slides down at the rate of this, how fast is the base of the ladder moving when it hits the pail? Okay, first things first. Number one, what does this want? What does the question want? Okay, now when I mean what does the question want, I'm talking about what does the question want in mathematical terms. Okay, so look at this. How fast is the base of the ladder moving when it hits the pail? This ladder would slide downwards, so it will move this way. The top of the ladder would slide this way. Am I correct? So let's call this direction x. If this direction is the x direction, then the speed, see how fast, the speed of this would be velocity in the x direction. Now if this is the y direction, then the speed at which this one is moving down is velocity in the y direction, vy, vx. Okay, that's what we have. So how fast is the base of the ladder moving when it hits the pail? The base of the ladder, this is the base. So what does the question want? The question wants vx, okay, velocity of x, which is also dx dt. If you remember, dx dt is velocity in x direction. This is what it wants. Second question, what are you given? Okay, what are you given? Well, the question tells you this is 3.5 meters. So this length here of the ladder is 3.5. Well, that's about it. The pail is placed 2 meters away, so there's supposed to be a pail here. Okay, let me just draw a pail with a handle. And this length here is 2 meters. You're going to make use of this information later on. Next, the ladder slides down. Okay, slides down at the rate of 0.4 meters per second. Means that this point here is sliding down at the rate of 0.4 meters per second. This tells you Vy. So Vy is 0.4 meters per second. Hang on. Y in the positive direction is this. So this is positive. So if you're going down, that's negative. So I must put a negative in front here. Okay? So Vy is negative 0.4 meters per second. So first, find out what does the question want. Second, what are you given? List as many of them as you can. Now the third thing, and this is what I feel is my own personal trick. Okay, the third thing you need to do is set up this equation. In, I would say, practically all of the related rates questions that you find in EG2, you can do this. Okay, right? Something over dt, I don't know what the something is. Something over dt equals to something over something times something over dt. And I like to draw this. Right, dA here, A can be anything, okay, we're going to fill up A later, equals to dA, at the bottom here I'm going to call dB, and this one here is dB, okay. Imagine that I can cancel this, and cancel this, what would you get? dA over dt, right, so same thing, so imagine I can cancel it, but of course I'm not going to cancel it, this is part of my working right now, okay. So dA dt equals to dA by dB times dB over dt. How is this supposed to help us? Here's what you do. You replace the alphabets of A and B with things that are given in the question. Okay? So what do you have in the question? I have Y and I have X. So can you see that dy dt equals to dy dx times dx dt? Link it back to this one. What do you want? You can see it quite clearly now. This is what we want. If we find this, we solve the question. What are you given? You are given this. dy dt is given to you. Next, how do I find dy dx? Okay, if I find dy dx, then I basically can solve the question already because I already know dy dt. I want to find dx dt. This is what I need. So how do I find dy dt? How do I find dy dx? Before you can find dy dx, you need an equation. Okay, so number 4, set up an equation, okay, to differentiate. What equation would that be? This is where related rates becomes difficult. No equation is given to you in the question. You need to be able to see it. Okay, so let me just draw this triangle again here. This is my ladder. This is 3.5. This length here is 3.5. This length here is x. This one here is y. And it is a right angle triangle. So based on Pythagoras theorem, I know that I can write this. The length square plus the height square equals to the hypotenuse square. Okay, if you press your calculator, this one here, okay, is equals to 12.25. So let me just write it here. This is equals to 12.25. Okay, this one, press calculator, you get this 12.25. So what I want to do is I can make y the subject. How do I do that? I bring my x squared over to this side and then I square root the whole thing. So I get 12.25 minus x squared square root. I can choose not to write it as a square root, of course. I can choose to write it as this to the power half. So when I differentiate dy dx, remember this is what I want now, okay? I have solved dy dt, I want to find dx dt, okay? This is what I want to find for the question. So I'm still missing dy dx. So dy dx, differentiate this with respect to x, okay? Let's use the chain rule. Bring down the half, write the same thing, 12.25 minus x squared. Reduce the power by 1. So it used to be half minus 1, I will get minus half. Okay. Now before you forget, you're supposed to differentiate what's inside here as well and write it down here. So I get minus 2x. Okay. Now this part here, before you go and simplify this, okay, there really isn't a need to simplify. If you want to, you can, okay, but you don't have to because I want to find the value of dy dx and x is already given to me. See, in the question they gave you, the pail is placed 2 meters away from the wall. So my x is 2. Okay, substitute 2 inside x here. So there's an x here, substitute 2 inside. And what you can do is, you can punch in everything and press your calculator. Okay, so when x equals to 2, dy dx equals to, let me just get rid of this, dy dx equals to, press your calculator, you will get 0.6963. That's my value of dy dx. So, put my value of dy dx here, okay, put it inside here. So what you have here is, dy dt is 0.4, negative 0.4, sorry, equals to 0.6963 times dx dt. So from here, what's my dx dt? Dx dt is simply equals to negative 0.4 divided by, oops, sorry, there should be a negative here, divided by negative 0.6963, and the answer you would get is 0.57. Write your units, meters per second. Check your answer. This is correct.